Good afternoon. Welcome, I'm Mohan Kumar. I'm a fellow at Intel, and I lead the Intel's cloud architecture team in the data center group. And today's session, I'm going to touch on a lot of things that we do in terms of technology innovation at Intel that kind of also has an impact at the OCP level. And I'm going to, I forgot the clicker works. I'm going to touch on some of the, heard in the keynotes, the fact that sustainability is a project. So I'm going to talk about some of the work that we've been doing on sustainability, hopefully get into a little bit more detail than they could get to in there. So one of the topics I touched on last time when I was here was on immersion cooling, touch on that topic, and then touch on various topics like platform security, open firmware, and some of the firmware enhancements that we are working on. And again, we are in a blessed situation that we have more technology from us than we can talk about in 25 minutes. So I'll do my best to cram everything here. Before we get into the technical portions of it, just a quick overview of the public cloud growth. Is continuing to grow in spite of all the stuff that we are in. Right now, by 2025, the e-commerce is expected to be $7 trillion. Digital advertising is supposed to be close to $1 trillion. Digital content is like $500 billion. And I mean, these are all big numbers. Cloud services is 330 million. These are all big numbers. And the significance of these big numbers is, with these big numbers, there is big growth in terms of data center infrastructure, which is what's critical to us in some sense, right? So there is increasing adoption of by enterprise of the cloud, and the hyperscale market is growing at a pretty good clip, all the way from now to 2029, which is the forecast in the slides that you see there. So this overall sets up the story for my first topic, which is sustainability, right? So if you're growing at this scale, what else is growing, right? Let's talk about that, right? So the first thing that's growing is that if you're growing at the scale at the data center level, the power that you consume is also growing at the same clip, right? So I think earlier in one of the keynotes, DJ showed a chart. Hopefully this is aligned with his numbers. So we're expecting power consumption by hyperscalers to grow at about a 30% CAGR, right? That's a pretty hefty CAGR to grow power consumption at. Well, but it's not surprising. They're growing at 30%. So the power consumption is continuing to grow at that clip. So by this projection, worldwide energy consumption is, so by just the hyperscalers, is going to be 250 billion kilowatt hours. To put a scale on that, the total energy that's produced is about 23,000 billion kilowatt hours. So 1% of the worldwide energy just goes to power these data centers, right? That's a lot of energy going into this type of environment. And if you look at where this energy goes, the pie chart there shows you kind of the rough breakdown. And there are multiple views of this type of a pie chart, but so essentially half of it goes to the cooling and the IT infrastructure stuff. About 20 to 30% goes towards the server and storage infrastructure that's in there, right? If you add up the networking and so on, maybe close to 40% is going towards that. And so this is our problem statement, right? So as it continues to grow, and we are dealing with this emerging growth, what do we do? What can we do, right? So this basically gives us energy. Basically translates into carbon footprint for us, right? So from a sustainability standpoint, there are two big sources of carbon that you're dealing with, right? One is the embodied carbon that comes from manufacturing of the part itself, or the server, whatever the component you're talking about. And the other one is the operational carbon, which is essentially from running the data center. We kind of classify it as scope 3. I know DJ called it scope 2 in his keynote today, but it doesn't matter which scope you're talking about. But it's coming from the fact that you're operating this thing. And as you can see from the purple portion of the bar, that is your dominant part, right? The purple portion is like almost 90%, and the embodied carbon is only 10%, right? So if you're going to go for an optimization problem, not that either one is less or more important, but we need to go solve the problem of the operational carbon, right? Because it's an ongoing problem that's going to continue as you run your data centers, and that's not to say that we're not going to focus on the 10% problem. We are committed to basically reducing the embodied carbon by going to green manufacturing our period of time, and we have our 2030 goals to be completely green, or carbon neutral, I should say. So solving this problem is not going to be at a single level, right? You can't just go say operational carbon is coming from, as I showed you from the pie chart, it's coming from all kinds of things. So you can't just solve it at one level. So you have to solve it at the silicon level. There is a lot of power management and telemetry hooks, but they are used for completely different purposes today. They're not used for sustainability. They're used more for, when the system is idle, what do I do, right? But taking the knobs and using them for something where I'm running, I'm still actively using a workload, but I still need to save power. That's a different paradigm than the one that we have right now, right? So so going from today to sustainability optimized, that's the paradigm shift we need to have. And second, from a monolithic platform of today, right? The left-hand side is showing the monolithic platform, right? Is CPU, memory, network, storage, all of them in the same motherboard. To more of a disaggregated platform. Blue Glacier that we're doing at OCP is an example of that type of platform. It not only saves you on embodied carbon because you're disaggregating the parts, and therefore you don't have to upgrade all of them, so there is a lot of recycling of reuse, I should say. But it also allows you, because common elements can be used across multiple servers, you reduce the overall operational consumption, and that helps with the operational cost that going into this. And from as I showed you, the data center infrastructure is a large portion of it. It's almost 50% of it. So what do? We can go to things like immersion cooling. I'll show you later on how much value it will bring, but essentially it changes the TCO. The pie chart I showed you in the previous slide was based on a typical data center that has a 2.0 something PUE, right? With the immersion cooling, you would hit close to a 1 PUE data center, and that change, what gives you the benefit that you would see from an operational standpoint in reducing your operational carbon. And similarly, we can do the power infrastructure reduction. I think one of the keynotes talked about that. I forget who talked about it, like going maybe to an Alexis, going to 48 volts, changing the inefficiencies in the power delivery into the data center, from the data center into the server, will go a long way in solving this problem. And then lastly, you have to reject the heat that comes out of the data center. And today we pay energy to reject that heat, right? And one of the things is that what if we basically recover and reuse that heat, right? Whether it goes into district heating or a building heating, and that way, and that's the other portion. So these are all the, so it's a holistic approach that looks top to bottom from data center, from the top all the way to the silicon. That's the only way we're going to solve this problem. You can't just focus on one problem and say you're going to get done, because that pie chart is telling, right? Solving some smaller portions is not going to give you the value prop you need. And lastly, we need to actually change our sustainability metrics, because some of the sustainability metrics are like PUE. I mean, average PUE is already reaching closer to 1. Like most companies are 1.1 at least in the West Coast. Where do you go from 1.1? So there are better metrics are needed essentially for us, and we are working on that as well. So on the power management side, as I mentioned earlier, we have lots of hardware hooks. So we have RAPL, we have turbo technologies, we have a thing called we have the ability to change the on-core frequency independent of the core frequency. You can scale the core separately. A lot of technologies. And then every OS has got infrastructure for power management that's laid on top of that. But unfortunately, these are tied together for idle power management today. There is no tie-in to the top layer, which is the cloud OS, that essentially says, I'm scheduling this workload, and this workload expects this TCO from you. If you're not, sorry, not TCO, service level agreement from you. If you're not delivering the service level agreement, you have failed, and essentially deliver that service level, right? So as a quick example, we have a demo running at the Intel booth where we took a workload and essentially took it from the performance mode that it typically runs in and essentially run it in a power optimized mode by essentially tracking the latency and making sure that we are always maintaining the latency within a certain acceptable SLO level. And we see that we can save about 20% savings by just doing that one thing. But again, this is why you can't do this in isolation. This is not a silicon technology only problem. This is a silicon OS and cloud orchestration working together to essentially deliver this value. And there is a QR code there. Tomorrow there is another session on telemetry where I'll have a chance to get more into the details, limited on time today. Switching topics, on immersion cooling, I mentioned that this has been a topic that's near and dear to us because of the potential it has. Essentially, if you can see from the graph, going from left to right from air to immersion, essentially the cooling that you get is about 15 to 30% savings in, this is operational power, right? I'm not talking about anything else. And the reason you're getting the operational power is that you're going to something that's a PUE of almost 1. It's 1.07 is what we typically are. 1.07 is what they're tracking to. And that lowering of the PUE, elimination of all the data center level fans, system level fans, makes a big delta. Because if you notice, the blue bar didn't change, right? The IT hardware is basically drawing the same amount of power, but by changing the data center infrastructure, you're able to save, you're able to improve your operational carbon substantially. Secondly, having immersion cooling basically allows you to have a higher outlet temperature, and higher outlet temperature allows you to do heat recovery out of that much better. And so you can take that heat and use it for residential district heating or urban farming, various purposes where they value that low-grade heat. So you save twice, right? You save from not having to expend energy to reject that heat, and then you save energy again by not having to pay for creating that heat in the second place, right? So it's a win-win in some sense. So this is our view of what we are doing to support sustainability, but we have also been working with partners like Tencent. And rather than me talk about it, I would like to invite Yan Zhao, who is a distinguished engineer and VP at Tencent, to tell you what we've been doing with them.
Thanks. It's a pleasure to be here and talk about what we are doing at Tencent and what we do the liquid cooling stuff. As people know, you want to save the cost, you want to lower the TCO, you want to pack more cores, more power into a single package. Then while we enjoy the benefit of this lower TCO, the cost comes here too. The problems is here. And first, the power through out the roof is very hard to cool. And secondly, so your PUE number going to be really high. And also, the TK's number going to dropping dramatically, so make it the cooling very hard. So we can come along working with Mohan's team together. We do the liquid cooling stuff, but we didn't do all the way to the immersion cooling yet. What we do is because our data center is structure, and we did a cold plate liquid cooling. The first thing we did, we built two mini data center. And one is air-cooled, one is liquid cooled. And we operate those two data center at the same amount of server and the same workload for about 6 months. We compare the PUE, and we see the huge advantage. So that shows the future is the liquid cooling. So you want to get your PUE much lower than what you have now. And plus, you have to deal with the increased power, also the lower TKs. I think that's the benefit of why we are doing this. And that's our story.
Yeah. Thank you. Thank you, Jan. Thank you, Tencent, for your partnership.
Thank you.
So You may ask, how does this all relate to what we are doing with OCP? So we are working, I wrote this slide before today's announcement, so there was no sustainability project, so forgive me for coding the other projects here. So we're working with the DC facility on creating the new metrics to go beyond PUE. We are working with the server project on the modular systems, of course, and then we are working with the strategic initiatives, which will become sustainability initiative on immersion cooling and data center sustainability and the platform telemetry stuff, and then the data center heat reuse, of course, since in the cooling environments project. So there is it's a few sessions here that tomorrow and day after that are going to get into more into the details if you want to, if you're interested in hearing more about these things. So now changing gears, is this all we do on sustainability? No, we do a lot more. So I wanted to talk to you about some of the new technologies that we are working on. So again, you probably heard about Project Kirkland in one of the keynotes today. So essentially the goal here is securing the TPM access. So the picture on the left is just a traditional Intel Xeon with the PCH connected to a TPM. TPM has been a secure chip on the platforms for almost a decade now, right? A perfectly good secure chip. The problem is not the TPM. The TPM is very secure, but the channel to the TPM is not. The channel, as you've shown here, is this PI bus, right? And there is no physical security to that PI bus. So for under $20, you can buy an interposer that you can put in between, and you can essentially spoof the traffic that's coming out of the TPM. In a world now that we are going to an edge-based environments where you cannot assume like this data center security model with a glass door and a security guard anymore, it is important for us to go solve this problem. So what we did was essentially took the solution and used SPDM-based authentication between the Intel's management engine and the TPM to essentially create a secure session and then pass the commands basically based on the secure session. You can see this demo at the Intel booth. This is part of Project Kirkland between Intel, Microsoft, Infineon, and Google. So the commands are defined as part of the community that's part of OCP. But we're happy to let you know that we actually have, my kudos to the engineers from the teams because they work day and night to get this all done so we can show it here. And the other project that we are proud to participate is in the open system firmware. And the goal of the open system firmware was essentially to get to a model where Intel's firmware, what we call firmware support package or FSP, essentially comes in and initializes the platform, initialize the silicon, initialize the platform, and then the rest of the BIOS orchestration layer is left to open firmware, right? Slim boot, core boot, right? It's not tied to a proprietary firmware stack. And that's the idea that we started with. And we started with a proof of concept in 2019 with Tioga Pass. And that matured into something more in our Cooper Lake, Delta Lake servers that we were able to demonstrate last year. And this year, we are happy to note that it's no longer, you can see the bubbles growing and more ODMs and software vendors and even adopters of this technology showing up, which is very gratifying to see. And this is, it says future because it's Sapphire Rapids is not announced, it's not officially shipping yet, but the goal is to have it be available. So we're doing our best to basically get there because we think it will change the industry because there is a lot of folks that want to have the transparency, the ability to debug faster, and the reliability that comes along with having that software stack that's open, and this gives them that openness as we go from there. So the second place where again the openness plays into is to basically build the BMC firmware, right? So the server hardware consists of the BIOS, which we talked about, and then the BMC, and so which is what we want to see as a full solution. And the BMC firmware is built using the Linux Foundation's OpenBMC. Again, being open allows you to be more secure. There is more transparency. You can customize better, right? Interoperability is better. So all the goodness that it brings. And we've been working on it. Our reference platforms, starting from the last generation, which is Ice Lake, have been based on OpenBMC already. So this is a journey that will continue. And we have also partnered with AMI to ensure that the release into OCP of OpenBMC basically comprehends our own Intel's OpenBMC repository, right? And there is a session later today on empowering robust open source ecosystem that AMI CEO Sanjay Maity is going to deliver, and I'm going to be a guest speaker on that one. And I will talk more about the actual tree, the trees, and how they are connected together to form what forms the OCP's OpenBMC tree. In that session, if you have the time, please attend. It's at 4:35. And lastly, one of the surprising things is that we all worry about hardware-based downtimes, like errors taking down the systems and so on. And this chart shows that the hardware errors are about 10%, and the planned downtime is 3x that at 30%, right? And the planned downtime basically comes from firmware updates, system updates, OS patching, the kind of routine stuff that you do, right? But it has a huge impact on fleet maintenance, essentially, right? And this is a problem that we know plagues many data centers, so we want to solve this problem holistically, both from an Intel standpoint and from an OCP standpoint, right? So one of the key things is, first of all, agreeing what represents a blackout, right? What is a blackout you're willing to tolerate, right? If the blackout is, for example, within the confines of a TCP/IP timeout, none the wiser, right? You just went out and came back, and nobody knows. And we are also working on some innovations that we want to bring into OCP on essentially, how do you do firmware upgrades without taking downtime in this space. So there is a lot that we're doing. There is actually a focus session on this again. I believe, I don't know if it's tomorrow, but the QR code should tell you to get more into the details, and we're going to invite you to come attend that session. I know I'm running out of time, so I would conclude here with the call to action to come engage with us on all the topics I talked about on the sustainability, which is a multidisciplinary approach. So no matter what your background and area of interest is, there is probably something we can do together in this space. Immersion cooling, we just released the immersion cooling spec, which is a first for the industry, where somebody can actually take a fluid and say, yes, it's going to be compatible, right? So, because otherwise we have this challenging problem of how do you take the hardware and put it into this liquid and be able to stand behind it? There is no figure of merit. And for the first time in OCP, we're actually defining that figure of merit. And we're also bringing some of the firmware innovations, both from an open firmware and in terms of doing fleet maintenance in there. And from an Intel standpoint, we have a bunch of demos on various things, on the Project Kirkland and on sustainability, network telemetry, and on modular systems. We will invite you to come see those and participate with us in this OCP. So I think I'm down to exactly 1 minute, so I will thank you for your attention and have a great evening. Thank you.